How's everybody doing out there? Well, welcome to day one of Corona Online School and Math 127. So I was pretty excited to see a lot of familiar names on the class roster, so it's good to have a couple of you guys for the second. This is a couple of people for the third time, which is very, very exciting. Kind of disappointed I won't get to see you guys in person, but hopefully I'll have some videos and stuff like that where you'll be able to see me and I'll be able to see you and stuff like that. So typically, when we have first day of class, usually what I do is to have kind of like an introductory thing so everybody gets to know each other in class. So obviously we can't do that since we're not face to face. But I thought what we would do is just have everybody kind of upload a little video of themselves, and I'll do one myself, so I won't talk about me in this video. I'll save this just for math. And then we'll share it all to the collaboration page. That way we can start putting faces with names and things like that for the students that I've never had before. So it'll be nice to actually get to meet you guys for the first time. And again, same for other students, so that way you get to recognize some of the other students in the class. And then technically, after we get that done, usually the first day, then we have to talk about the syllabus. So at this point, I'm just going to leave the syllabus for you guys to read over. And if you have any questions about anything related to the syllabus, feel free to post it up on the message board and stuff like that. So that way I can answer the questions, or if it's a good question, I'll post it up so that way everybody can kind of take a look at it and see what's going on. So otherwise, with that stuff out of the way, I think we should just go ahead and dive in and start working on some math here. So for the students that have had 113, if you thought you had a lot of definitions in that class, well, you haven't seen anything yet. Statistics is just filled with definitions. So, and this first chapter, is no exception. So statistics is kind of an interesting class and a weird class all the same time. So I think it's a nice class for students to take, especially as a kind of a regular math class, just because you can't do anything in the world without looking at statistics. So right now we've got a lot of interesting thing going on between the 2020 census coming up, the 2020 election going on. I mean, you probably see polls out the wazoo talking about, different presidential candidates, popularity contests, things like that. So everything involving those are statistics. And so the nice thing is, if you've never really taken a statistics class, you kind of take whatever they say at their word. And that's one of the nice things when you take this class, it'll start to make you question everything because unfortunately, you can kind of manipulate statistics to be different ways. So even though the numbers are all the same, you can kind of spin the data in different ways to make it look in favor of whatever thing you're trying to support and stuff like that. So even though it's a math class and like you have answers, that's one of the things that makes statistics so weird. And we'll talk about some of that stuff as we come along, because if you do some bad sampling or things like that, you can kind of force numbers to be in favor of what you want to predict. And so it's bizarre. So statistics is a fun class, but it is a little bizarre for that reason. It's kind of a strange math class. So just to kind of go through a little bit of these, like I don't want to bore you and read all the definitions, and there's some of them that are going to be on a PowerPoint for you guys to fill out, but some of the main ones are in this first section, so I will kind of touch upon some of those for you. So in this case, I was talking a little bit about the census. So again, that's coming up. Here's some typical data that you might see for a census. And for statistics, the two things that we're always trying to do is we're trying to, collect data somehow, organize that data in some way that it makes sense and that we can do something with it. And then finally, use that data to predict something about that data. So statistics is really broken up into two types of categories. So what we've got is what's called descriptive statistics and inferential statistics. So kind of the first half of the class, we're going to be dealing with descriptive statistics. The second half will be the inferential statistics. So if we look, descriptive statistics is talking about the organizing and summarizing of data. So again, data comes in lots of different forms. I mean, it could be yes, no questions. It could be like people's heights and stuff like that. And so what you have to do is kind of put it in some kind of an order. So you put it in a table, something like that. You can make graphs of it. And so And basically, it allows you to look at what the data looks like. So descriptive describes the data some way, whether it's visually or whether it's talking about like means and stuff like that. Where inferential statistics is you're trying to actually make kind of an assumption based on the data. So they're both interesting, they're both fun. Inferential statistics can be a little bit trickier because again you're trying to like make conclusions about the data, but at the same time it's they're all fun, it's kind of neat. So again, just to kind of scroll up and get into some of these definitions. So again, a lot of the ones in this first section are going to be the main definitions that we're going to be talking about. So population's of course the most important thing. So the population is the group that we're interested in studying. So for example, the 2020 census is interested in studying the population of all people in the United States. If we were doing something more local, like at FCC, like we might want to talk about textbook prices at FCC. So again, in that case, the population would be all students that are buying textbooks at FCC. So a sample is the amount of people that we actually study. So, because the problem is when you're talking about populations, they can be quite large and it's kind of hard to talk to every single person in the population. So, a lot of times, what we'll do is we'll try to find a small sample and use that sample to actually make a prediction about the whole population. And so, we'll talk more about sampling in the next section, but that's kind of where we want to go. And the main thing that we want to be careful of with a sample is we want to make sure that our sample is representative of the population that we're actually trying to sample. So for example, if we were talking about textbook prices at FCC and we were trying to get a judge of what everybody was spending or something like that, if we only surveyed like female students, well, that wouldn't necessarily be representative of FCC because there's males, there's females. We've got all different kinds of students on campus, so just picking like one group wouldn't necessarily be representative. So you're trying to make sure that your sample kind of looks like your population. And so if it does, then that means your sample will usually be, your statistics will usually be pretty good. If the sample doesn't really look like the population, I mean, it could be pretty terrible. So again, sampling is going to be one of the most important things that we talk about in this course, and it's going to determine whether your statistics are good or bad. All right, so a parameter is a number that describes something about the population. So notice parameter starts with a P, population starts with a P. So again, the parameter is relating back to that population, the whole group that we're actually trying to study. So for example, if we were looking at the average salary of every US worker, that would be the parameter in that case because it's describing the population. Where on the other hand, a statistic, so again, S and S, the number that describes something about the sample. So in this case, the average salary of every worker in our sample. So notice the first one talked about every worker in the US, which was our population, but the statistic is just referring to the people that were actually in our sample. And so just like the next paragraph says, every parameter has a corresponding statistic. And again, if we do a good job sampling, that statistic should give us a good estimate of the actual parameter without having to actually go around and ask every single person in the United States or every single person at FCC in that case. So again, if we look talking about descriptive and inferential statistics, in general, when we're dealing with the sample, we're doing descriptive statistics. We're describing the sample, and wherever we're using the sample to draw conclusions, then we're doing inferential statistics in that case. So when we're trying to make some kind of an assumption about the population, then that's when we're doing inferential statistics. All right. So now we want to talk about some different types of variables that can occur in statistics. So a variable itself is just something that we record about our sample. So after we record it, collect the data, like in a table, we can start to describe it by taking the average, drawing a graph or something with it. So again, the variable from like the little examples we were doing above would be the people's salary in the US or textbook cost. Those would be the variables that we would have in those cases. So there's couple different types of variables that we can have. So we can have numerical or quantitative variables. So variables that we find when we measure or count. So for example, the number of household cars in a household, age of household members. So anything that we can actually count would be, so we're not looking at like yes, no questions or things like that. We're not looking for opinion questions. We're looking for things that we can actually calculate data with. So things we can take averages of, stuff like that. And so numerical values actually come in two different kinds of categories. So they can either be discrete or they can be continuous. So discrete, you want to think of it as like the counting numbers. So they have to be whole numbers in that case. So 0, 1, 2, 3, 4, things like that. So for example, when we're talking about the number of children, you can't have like 3.14 children. So that would be a good thing to talk about discrete variables. Where continuous, on the other hand, can include decimals, fractions, things like that. So if you were talking about height, height would be a good example of a continuous variable because it doesn't necessarily have to be just 5. It could be 5.23 inches. It could be, stuff like that. So, or 5.23 feet or whatever. So those are the two different kind of numerical variables we can have. And then we can also have non-numerical or qualitative data, which again could be like yes, no questions, could be opinion questions. It could be things like your student ID, which even though it's a number, it's a category. It's describing who you are to the FCC community. We wouldn't add it together, we wouldn't average it or anything like that. So it's that kind of data. So those are the different kind of variables and things like that. And so again, everything's kind of written out there so you can kind of take a look. And so again, just to kind of summarize, here's the key terms again. So population is the group that we're interested in. Samples, the subset of the population that we can actually study. Parameters, the number that describes something about the population variable. Statistics, a number that describes something about the sample variable. The variable is something that we record about our sample. Quantitative variable is again a numeric variable that's either discrete or continuous. Qualitative is kind of yes, no, student ID, social security number, things like that. All right, so let's take a look at example 1 here. So what we've got is we've got a bunch of different terms. We're going to try to figure out what's the population, what's the parameter, what's the statistics, what's the sample, what's the variable, and kind of match these guys up. So a study was conducted at a local college to analyze the average cumulative GPA of students who graduated last year. Fill in the letter or the phrase that best describes each of the items below. So in this case, you can do it either way, like if you want to read through A, B, C, D, E, and F first and try to figure out which one they are, or if you want to go number 1 first, doesn't matter to me. So in this case, I'm looking at all students who attended the college last year, the cumulative GPA of one student who graduated from the college last year, a group of students who graduated from the college last year randomly selected, the average cumulative GPA of students who graduated from the college last year, all students who graduated from the college last year, and the average cumulative GPA of students who graduated from the college last year. So let's see. So in this case, we're trying to figure out each of the items below. So in this case, it looks like our population would be all students who graduated from the college last year would be our population. So in this case, that would be our E. And so let's scratch that out. And so with that with mind, like I'd probably go with the sample next and try to figure out which one of these students would look like the sample. So in this case, the group of students who graduated from the college last year that was randomly selected, so the randomly selected is going to be the smaller group, so that's going to be our sample in this case, so that gives us C. So let's see if we can figure out the parameter, which is the thing that goes with the population. So in this case, we're looking for the variable that goes with the population. So in this case, we would get D, so the average cumulative GPA of students who graduated from the college last year would be our parameter. And the statistic, in this case, so this is going to be the thing that goes with the sample, is going to be the average cumulative GPA of students in the study who graduated from the college last year. So again, because they're part of the study, they're the ones that we actually chose in this case. So that gives us F. And then finally, the last thing on our list is the variable. And so the variable is usually going to be related to one student. So in this case, the cumulative GPA of one student who graduated from the college last year. So the variable in this case would be B. All right. Does that make sense to everybody? So if you need to, like I said, you can kind of erase this, practice this on your own just to kind of make sure we understand what the different parts mean. You know, population goes with parameters, statistic goes with sample, and then the variable is usually going to describe one individual person when we're talking about these guys. All right. All right, so let's move on to the second example here now that we've got this one down. So again, in this case, we're doing the exact same thing, but instead of having a kind of a matching, we're just going to write down in words what we think each of these different parts are going to be. So determine what the key terms in the following study are. So we want to know the average mean amount of money first-year college students spend at ABC College on school supplies that do not include books. We randomly surveyed 100 first-year students at the college. 3 of those students spent $150, $200, and $225 respectively. So in this case, the population is going to be all first-year students. At ABC College. So again, because the population is always the biggest amount, the sample is going to be those 100 that were randomly surveyed. So the sample is and hopefully they did a good job choosing the sample. Hopefully they didn't choose them all from like one big, lecture class or something like that. Hopefully they came up with some nice way to sample them so they got a nice representative sample. So in this case, the parameter is going to be the average amount of money spent by first-year college students at ABC this term. So it's going to be, so the parameter is so in this case of all students, where the statistics is basically the same thing, but it's just going to be the average amount of money spent of the people in the sample. And so the variable in this case, so remember it's always related to one student. So the variable is going to be the amount of money spent by one student. And then finally, data would actually be like the dollars amount spent by the different first year students. So in this case, like there was 150, 220, 225. So that was some of the data that was collected. So the data is spent by students. So again, if you have any questions about anything from 1.1, definitely let me know. So there's a couple practice ones for you guys to try, just like example 2 here. So we're going to try to take the sentence, try to decipher what the population is, sample, parameter, statistic, variable, data. So again, we're trying to practice these definitions, see if we can actually pull them out. So take good notes on this, because I am going to have you guys introduce or do some collaborations where you're going to put in some answers from all the different practice problems that we're going to work on today. So this is it for 1.1. So I'm going to do another video for 1.2 and then another video for 1.4. So go ahead and finish up 1.1, and when you're done with that, I'll meet you back for 1.2.